Session 7, Marine Science, How Science and Technology May Impact the Good Order at the Sea. This session will be moderated by Mr. Dinh, Director General of Vietnam Administration of Seas and Islands. Distinguished panelists in this session include Professor Mary Antoinette Menis, Marine Science Institute, the University of the Philippines. Dr. Nguyễn Chu Hồi, Associate Professor, Doctor of Vietnam National University, and Standing Vice Chairman of Vietnam Fisheries Society. Dr. Suk Jun Yoon, retired Captain of the Republic of Korea Navy, Senior Research Fellow of the Korean Institute for Military Affairs. Dr. Peter Townsend Harris, Managing Director, GRID Adrender, from Norway. Mr. James Bolton, Non-Resident Fellow, Tufts University Science Diplomacy Center from the USA. And Dr. Eric Franks, Professor, Acting President of the Beijing Society of International Law. Mr. Dinh, the floor is yours.
Thank you. Good afternoon from Vietnam. Distinguished guests, ladies and gentlemen. Welcome you all to the section 7. As you know, the team Marine Science, how science and technology may impact the good order of the sea. I'm sure that all of you may agree that this is a very important topic as the marine science and technology would be a great source of the regional cooperation. We are honored to have such a great dean of distinguished panelists today. Let me introduce our panelists of the session. As the panelists will have your own presentation in order as follows. First, Professor Mary Antoinette Menis, Marine Science Institute, University of the Philippines. Second, we have on the floor Dr. Nguyễn Chu Hồi, Associate Professor, Doctor of Vietnam National University, and is the Standing Vice Chairman of Vietnam Fisheries Society, Vietnam. And third one, please welcome Dr. Suk Jun Yoon, retired Captain of Republic of Korea Navy, Senior Research Fellow at the Korean Institute of Military Affairs, Republic of Korea. Fourth, Dr. Peter Townsend Harris, Managing Director, GRIPS, Arendal, Norway. And fifth, Mr. James Bolton, Non-Resident Fellow, Tufts University Science Diplomacy Center, USA. And final, Dr. Eric Frank, Acting President of the Belgian Society of International Law Center, Belgium. Let me remind all of panelists some housekeeping regulation of the section. First is the panelists will have a maximum of 7 minutes to present their own job paper. Please strictly follow that 7 minutes rule. And second, online attendants are able to raise your question by using a Q&A function in Zoom, and please vote for the question that you think that the authority of be asked. And once again, thank you very much. And first of all, I would like to invite Professor Mary Antoinette Menis. Please, Professor.
Good afternoon. May I share my screen now? Okay. So first of all, it is an honor for me to be invited in this conference and to be able to share my insights and perspectives on the benefits of marine science and development cooperation in the region, the constraints, and the opportunities for the future. We all know that the South China Sea is of global importance in relation to marine biodiversity, navigation, international trade, fisheries, and more so for the well-being of the populations in the region, including the future generations. Thus, despite territorial disputes, there has always been a culture and openness for collaboration and cooperation in marine scientific research and in the promotion of science-based knowledge in the region to address common threats and needs. Through various multilateral scientific and development cooperative programs, scientists in the region have worked together to address issues related to environmental protection, habitat degradation, particularly of coastal areas, land pollution, fisheries overexploitation, as well as conservation of species and ocean health. Aside from these programs, there are regional institutions such as the IOC Westpac that promote the advancement of ocean sciences in the region, as well as the training and development. In addition, there are intergovernmental agreements, notably from the South China Sea, as well as states in the Pacific, particularly in relation to the Coral Triangle, which is the center of marine biodiversity. There have also been bilateral intergovernmental agreements, particularly the joint oceanographic marine scientific research between the Philippines and Indonesia, to generate new knowledge, as well as joint policy recommendations, for example, on marine protected areas. Marine science and technology is an important component of the science, technology, and innovation initiatives of ASEAN. Since 1980s, there have been various programs with different partners on marine pollution, red tide, coastal resources management, among others. Currently, there is a cooperative action initiative in ASEAN +3 on marine plastic debris. All of these cooperative programs have provided immense opportunities and much needed opportunities for capability building in marine sciences in the region. Networking among regional scientists, as in membership in technical working groups, or working together to organize and participate scientific conferences and various training, collaboration in research projects, and even joint publications have fostered through the years a lot of goodwill and openness among the scientific and technology community in the South China Sea. This has as well been an important contribution to confidence building efforts. However, there are barriers and constraints. Foremost is mistrust, particularly in relation to the Chinese actions, resulting in the degradation and loss of critical reef ecosystems through artificial island building, rampant poaching of endangered species such as marine turtles and giant clams. There is also a great variance in the level of science and technology capabilities among the littoral states in the South China Sea, which prevents more meaningful cooperation, particularly in more advanced ocean sciences and, for example, oceanography. There are also not many marine scientists in many countries for different fields, especially when you compare it to the capabilities and expertise in China. Because of the limited resources, the focus of many states are on immediate national concerns rather than broader scale, transboundary global issues outside international cooperative programs. However, there are now many strategic opportunities for enhanced cooperation. First is the growing change and transformation of standards in ocean governance that focuses on inclusive and sustainable development at all levels of governance, from local to global. This is seen in the UNCLOS, where they develop internationally binding instruments to govern the use of resources in the areas beyond national jurisdiction, as well as the launching of the Decade of the Ocean for Sustainable Development starting next year. In relation to marine biological diversity in areas beyond national jurisdiction, for example, one of the most contentious areas is access and benefit sharing in relation to marine genetic resources. And one of the non-monetary benefits stipulated is the provision of training and capability building for less developed researchers, in countries from less developed researchers. Likewise, the Decade of the Ocean, this is one of the priority thrusts as well. These initiatives will accelerate the reduction of the asymmetry in knowledge, skills, and access to technology, which has constrained more meaningful cooperation in the region. Secondly, the significant advances in ocean technologies will not only promote expansion and perhaps joint development in relation to ocean-based economic activities, but will also help address ocean-related environmental challenges on different scales. Aside from the global ocean observation systems, there are now autonomous underwater vehicles, remote environmental monitoring units that will allow monitoring reefs, deep sea, and the open water. Also, the developments in satellite imagery has been invaluable in providing information on change over time in terms of physical changes, fine and broad scale. Here's an example of Subi Reef. It is one of the offshore reefs that was converted into artificial islands. And you will see the development. It now has a military installation. Access to real-time information such as this should promote transparency and accountability, and hopefully encourage more responsible behaviors among states in the South China Sea. Related to this, there is a call for ocean sciences to be transformed such that the science and technology sector expand their role beyond knowledge generation and education capability building to becoming partners in finding solutions to address the triple bottom lines of sustainable development and realize the goals of a sustainable future. Finally, there is heightened understanding of the close interactions of human and natural systems and the importance of science and cooperation. As we all know, this has been catalyzed by global issues, particularly the COVID-19 pandemic and the impacts of climate change, which is affecting millions of people all over the world. In addition to more ready access to knowledge and information by many stakeholders, including the public, this will promote the demand for good governance, which is very important to change the values and the norms at different scales. Thus, to sum up, taken together, the developments in science, technology, and governance, in addition to the support from the international community and multi-sectoral partnerships, provide a lot of opportunities to enhance cooperation that will result in the realization of science-based cooperative actions to address transboundary environmental and resource utilization issues that we have long discussed in the region, such as marine protected areas, regional fisheries management, disaster risk reduction, and many other issues that have been discussed in this conference. I thank you for your attention, and I thank the organizers of the committee for providing this additional venue regularly for exchange of information.
Thank you very much, Professor Mele. Your presentation keeps on time. Thank you very much. And we made that science is a vital key for the more sustainable future. And marine scientific research is among the area for maritime cooperation among states in the region. In particular for the East Sea, South China Sea, and the Gulf of Thailand. In last decade, UN decade for the ocean sustainable development. Scientific and technological advance may have the better address the ocean related environmental challenges and the further cooperation and development of the ocean-based industry. Now, I would like to invite Dr. Nguyễn Chu Hồi. Have your own presentation, please, Dr. Chu Hồi.
Thank you, Mr. Chairman, ladies and gentlemen. Welcome to my friend panelists with me. And I have prepared my presentation under title Science and Technology Cooperation toward a blue and peaceful South China Sea. It is a general and a common topic, but I have only 7 minutes, so I would like to speak Vietnamese. I can speak more. Sorry. Error technical. Như các quý vị biết thì trong Biển Đông thì tôi cho rằng là có hai vấn đề quan trọng đứng kể cả mặt tiềm năng và thực tiễn. Đó là cái thứ nhất ấy, là đây là một cái điểm rất là nóng về tranh chấp chủ quyền và cái xu thế mà căng thẳng ở Biển Đông có vẻ như ngày càng gia tăng. Cái thứ hai là Biển Đông có thể nói một cái từ ví là cũng đang bị đầu độc bởi các cái nguồn ô nhiễm, bởi cái sự khai thác quá mức các nguồn tài nguyên, và cái điều này nó ảnh hưởng rất lớn đến cái mục đích duy trì một cái Biển Đông xanh, tức là cái Blue Southern Sea. Và cái việc mà căng thẳng thì nó ảnh hưởng đến cái môi trường hòa bình ở Biển Đông. Và có thể nói rằng là đây là hai mặt của một vấn đề. Đây là hai mặt của một vấn đề trong quá trình giải quyết để mà hướng tới một cái Biển Đông xanh và hòa bình. Đối với Việt Nam chúng tôi thì cái màu blue là cái màu xanh của kinh tế xanh và tăng trưởng xanh, cũng chính là cái màu xanh hòa bình. Cho nên tôi cho rằng là để giải quyết được nó chính là hai mặt của một vấn đề. Thế thì Biển Đông hiện nay là đang nằm ở trong một cái khu vực mà có rất nhiều thách thức. Có rất là nhiều thách thức khác nhau, và trước hết là có thể nói rằng cái thách thức đấy liên quan đến thách thức cả về hòa bình và thách thức ở Biển Đông, cũng như thách thức đến cái giá trị xanh ở Biển Đông. Trong đó là cái sự hạn chế hoặc cái sự rất khác nhau về nhận thức giữa các bên, đặc biệt là giữa các bên có cái tranh chấp ở Biển Đông. Cái thứ hai là cái vai trò rất hạn chế của khoa học công nghệ hợp tác để giải quyết các vấn đề, mà trong đó cái điều 6 mục B của DOC đã nói rất rõ là khuyến khích và tăng cường những vấn đề hợp tác ít nhạy cảm, trong đó có vấn đề về nghiên cứu biển và khoa học công nghệ. Và cái việc vai trò không rõ ràng của các cái bên liên quan cũng như là các công cụ để xử lý các vấn đề mà theo cái hướng là giải pháp hòa bình, và cái việc mà hợp tác khu vực và quốc tế liên quan tới những vấn đề ít nhạy cảm trong Biển Đông thì cũng đang rất là hạn chế. Việc sử dụng các cái nguồn tài nguyên, đặc biệt là vốn thiên nhiên, cái marine natural assets ấy, thì cũng thiếu hiệu quả và chưa bền vững. Và cái việc mà ô nhiễm biển cũng như là suy giảm các cái nguồn tài nguyên, trong đó có vốn tự nhiên biển, thì cũng gia tăng. Và cái tăng cái tác động hiện hữu của biến đổi khí hậu và biến đổi đại dương. Ngoài cái climate change thì những cái ocean change rất là rõ. Và đây là những cái hình ảnh mà chúng ta thấy rằng là những cái hành vi thiếu bền vững, trong đó có cả những vấn đề về xây đảo nhân tạo, phá hủy vĩnh viễn những cái môi trường ở quần đảo Trường Sa liên quan tới các rạn san hô mà bạn của tôi ở Philippines cũng đã, đồng nghiệp tôi cũng đã trình bày. Và cái biến đổi khí hậu, biến đổi đại dương trong các cái mô hình dự báo thì cho thấy rất rõ mực nước dâng, cái mức độ axit hóa đại dương trong các chương trình nghiên cứu của IUC SPAC cũng đã thừa nhận cái vấn đề đó. Và FAO thì công bố năm 2015 thì Biển Đông gần như bị con lép, cá, tôm là những cái vùng đỏ kia là để nói rằng những cái khu vực Biển Đông là không còn tôm cá hiểu theo nghĩa là tôm cá thương mại và tôm cá hàng hóa. Chính vì vậy những cái giải pháp mà phục vụ cho cái hướng xanh và hòa bình ở Biển Đông là rất cần thiết. Trong đó có cái việc mà cái hợp tác về khoa học công nghệ và xây dựng một cái thể chế mang cấp vùng về khoa học công nghệ. Chúng ta có DOC nhưng việc điều khiển nó bởi trực tiếp các chính phủ. Cho nên nhiều lần chúng tôi cũng tham gia những vấn đề rất ít, được gọi là ít nhạy cảm. Nhưng mà khi bàn một chập thì nó lại ra là nhạy cảm. Vì vậy mà mọi cái hợp tác gần như là bế tắc. Và tôi thì quan niệm rằng là khoa học công nghệ ở trong trường hợp này nó như là một cái công cụ, như một cái tool thôi. Nhưng mà khoa học công nghệ hợp tác để giải quyết vấn đề gì? Để giải quyết vấn đề bảo tồn đa dạng sinh học, phục hồi hệ sinh thái, hay là đánh giá những cái hiện trạng biến đổi về môi trường tài nguyên ở Biển Đông do cái hành vi ứng xử con người vân vân. Nó phải có mục tiêu, chứ nếu không cái hợp tác khoa học công nghệ thuần túy ở quy mô nhỏ, sau đó nghiệm thu lại đút ngăn kéo và không được ứng dụng. Và cái chuyện này thì trong cái hợp tác vừa rồi ở biển Đông chúng tôi, biển Nam Trung Hoa chúng tôi cũng thấy rằng là nó xảy ra như vậy. Và cái việc mà cái giải pháp làm sao tập trung vào khoa học công nghệ để mà cải thiện được cái chất lượng môi trường biển, cải thiện được cái hợp tác khoa học công nghệ cũng như là duy trì được cái vốn tự nhiên biển và tăng cường cái hợp tác quốc tế. Không ngoài cái ASEAN và Trung Quốc thì tôi nghĩ để thực hiện DOC thì tôi nghĩ rằng các cái yếu tố hợp tác quốc tế cũng nên được khuyến khích, và cái đầu tư vào các hệ sinh thái biển và ven bờ trong cái bối cảnh về biến đổi khí hậu và biến đổi đại dương hiện nay ở khu vực Biển Đông thì được xem như là đầu tư cho tương lai, một cái giải pháp rất quan trọng. Và để làm được cái điều đó thì chúng tôi cũng không hy vọng rằng là chúng tôi cũng tham gia cái này rất nhiều về cái lĩnh vực khoa học công nghệ để thực hiện DOC, cho nên tôi cũng không hy vọng rằng là nói ngày hôm nay để ngày mai có thể có một hợp tác hiện hữu, và cho nên là cái lời khuyên của tôi nó chỉ là thế này: một là hãy ứng dụng cái cách tiếp cận từng bước, thứ hai là sử dụng những quy mô nhỏ và một vài việc để chứng minh rằng là chúng ta đã củng cố được niềm tin trong cái quá trình hợp tác. Trên cơ sở đó thì mới tiến hành những cái hợp tác lớn, chứ nếu không thì có thể họp rất nhiều, bàn rất nhiều, nhưng như nãy tôi nói ấy, đưa những vấn đề cụ thể trong những cái chủ đề ít nhạy cảm, nhưng mà lý luận một lúc thì có nước nào đó không đồng ý thì lại chuyển nó thành vấn đề nhạy cảm. Cho nên là những cuộc họp đó rất tốn thời gian và rất tốn kinh phí, và đối với các nhà khoa học cũng không mong muốn. Vì vậy mà tôi rất nhất trí một học giả của những cái section nghề cá đấy có nói rằng là hãy làm một cái gì nhỏ và hãy bắt đầu từ các nhà khoa học. Đấy, cho nên là tôi đề nghị rằng là cái việc mà tăng cường một cái mối quan hệ đối tác giữa Trung Quốc và ASEAN để mà hỗ trợ phát triển một cách tốt hơn cái hợp tác khoa học công nghệ trong khu vực Biển Đông ở từng nước cũng như trong toàn khu vực, để mà góp phần vào việc thực hiện cái môi trường hòa bình cũng như là giữ cho Biển Đông xanh và theo cái hướng gọi là Blue Growth đấy, và thực hiện cái mục tiêu SDG 14 về đại dương, bảo đảm cái môi trường hòa bình Biển Đông là nên được ưu tiên. Và đối với cách tiếp cận từng bước thì có thể nói ví dụ một cái cụ thể là nó sẽ xác định và giúp được hai cái cơ chế đầu tiên tôi nghĩ rằng là phải đi. Cái thứ nhất phải xây dựng một cái thể chế khu vực, một cái mạng lưới của các nhà khoa học dưới dạng informal, không chính thức, và như vậy là trong cái trường hợp ấy để các nhà khoa học chia sẻ những cái sáng kiến ban đầu và lựa chọn những vấn đề có thể là có tính khả thi, và đồng thời thông qua những các cái mạng lưới hoạt động của các nhà khoa học trong khu vực ngồi được với nhau là một cái bước đầu tiên, thì có thể hy vọng rằng là tạo một cái niềm tin và một cái sự thuyết phục nhất định về mặt thực tiễn đối với các nhà hoạch định chính sách và các nhà ra quyết định, thậm chí để mà tạo ra một cái political win-win, tức là một cái thiện chí chính trị và một cái gì đó để mà tạo điều kiện cho khoa học công nghệ thực sự thực hiện, thì tôi cho rằng sẽ hiệu quả. Trên cơ sở đó thì bắt đầu xúc tiến một cái hợp tác hiệu quả về nghiên cứu khoa học biển thông qua cái điều 6 mục B của cái DOC đã được ký năm 2002 giữa Trung Quốc và ASEAN để hướng tới một cái Biển Đông xanh và hòa bình. Thì tôi cho rằng hãy làm một cái việc nhỏ nhưng mà làm thật ở cái cấp khu vực. Chứ còn cái hợp tác song phương và hợp tác nhỏ trong từng quốc gia thì vẫn có. Nhưng mà hợp tác toàn cái khu vực Biển Đông của những nước, đặc biệt những nước có cái lợi ích trực tiếp hoặc là đang có những cái tranh chấp, thì hiện nay là chưa có một cái đề án hoặc chương trình nào cụ thể như vậy. Và cái đó là cái điều mà tôi cho rằng là nếu tiếp diễn như thế, đấy là một cái điều thất bại. Và với cái mong muốn như thế thì tôi hy vọng rằng là hợp tác khoa học công nghệ sẽ đem lại hòa bình và sẽ hướng tới duy trì một Biển Đông xanh cho tương lai, cho một cái Biển Đông bền vững cho không chỉ là Trung Quốc mà tất cả các nước trong khu vực, cũng như là góp phần vào bảo đảm hòa bình và ổn định trong khu vực và trên toàn thế giới. Rất cảm ơn các quý vị đã chú ý lắng nghe. Tôi cũng xin chỉ lấy lại một chút thời gian do cái việc trục trặc kỹ thuật. Xin cảm ơn.
Thank you very much, Professor Chu Hoi, for your presentation. Provide us, the notion, the peace and blue solution towards developing blue economy or sustainable development of ocean economy. I think that all the country in the region, we go on from the small thing and, step-by-step approach And the science is a very play important for the peace and blue solution. Thank you, Professor Chu Hoi. Now, I would like to invite Dr. Jun. Please, Dr. Jun. Could you hear me, Dr. Jun?
You need to unmute.
Can you hear me?
Okay, thank you very much.
Oh, yes.
Dr. Jun.
Yeah. My name is Seok-Jun Yoon, Navy Captain, retired Republic of Korea Navy. I'm a senior research fellow of Korea Institute for Military Affairs. The topic I would like to discuss with you is how can science and technology contribute to maintaining good order at the South China Sea. The UNCLOS, United Nations Convention on the Law of the Sea, is based on the natural geographic feature. And since 1997, UNCLOS has been the customary mechanism for the solution of maritime dispute. Notwithstanding the provision of UNCLOS, however, the prevailing dispute of South China Sea has not been resolved through the application of a geographic and scientific fact. Instead, these considerations have been overshadowed by political and military implications. It is great hope of well-intended seekers, policymakers, researchers, and scholars that innovative development in marine technologies will allow a comprehensive determination of the objective scientific situation, which will prove acceptable for all parties. The present state of marine sciences and naval technology is unfortunately inadequate for this purpose. And there are currently no discussion on how to establish convergence of science and technologies to fully characterize the natural geographic feature which UNCLOS relies upon. Clearly, climate change is a particular challenge for which innovative development of science and technology will be critical in dealing with the new maritime crises, which are already happening and which will surely intensify the future, such as rising sea levels, recording hottest temperature, degradation of fishing stock, maritime environmental pollution, etc. However, so far, scientific and technological development have intended to increase tensions in the South China Sea by facilitating provocative activities. Indeed, naval development or deployment near the territorial seas or maritime zones claimed by disputing parties are particularly detrimental to maritime peace and stability of the South China Sea. Most obviously, U.S. freedom of navigation operation, OPCON, which entered surface, transit, overflight, unknown underwater operations through contested waters, have been greatly provocative. A conscience is developing among many leading policymakers, military planners, and the security researchers to stabilize security environment in the South China Sea. Certain lessons must be learned from current, chaotically unpredictable situation, and the application of innovative science and technology is now essential. First, the natural future required to be respected to UNCLOS rights and entitlements in the South China Sea must be preserved. Second, science and technology should make a positive contribution to maintaining the existing natural bumpers, and they should not be used to destabilize the state quo of the South China Sea. Third, advanced military science and technology should not be used for the political purpose. In particular, strategic competition between China and United States has promoted both to conduct coastal surveys for literal naval surface and underwater operations. And there are also US-led pornos intended to resist China's unilateral declaration of historical right and the straightforward base right. None of these activities are helpful in resolving disagreement among the parties involved in South China Sea dispute. So if a more stable security environment is ever to be established in the South China Sea, then the dispute parties need to be moved beyond their security architecture as it currently existed, based on the purely open methods of legality, and instead take into account the objective scientific and geographic facts in preparing for the future of climate change, biodiversity loss, technological disruption, and growing inequality. There are many issues which need to be considered. First, the future of the South China Sea depends upon the development of marine scientific and naval technologies. Second, marine scientific and naval technologies currently using for the provocative maritime construction, such as artificial island, or for the implementing new equipment, weapons, and systems for the naval forces, should instead to use positively to assisting in developing competence building mechanisms. Third, the prospective development of marine science and technology is expected to impact the dispute in the South China Sea, in particular, naval confrontation between the People's Liberation Army Navy and United States Navy. Fourth, sharing the fruit of marine science and naval technology with neighbors will be politically challenging, but it is essential. One scientific expert suggests me the advanced pyrolysis technologies, which melting down protein, plastic debris or rubbish in the South China Sea to produce oil and gas provide a good example. Commercial satellite images can also help avoid the spread of dangerous misinformation by providing evidence of compliance with international law and the multilateral agreement. Fifth, the weakest and the most vulnerable coastal states of South China Sea are clearly disadvantaged by their unequal access to the marine science and technology. Sixth, to establish a comprehensive and cooperative foundation of science and technology, which can support peace and good order in the South China Sea, the people of the region needed to be involved. Seventh, many important South China Sea quantitative figures are currently contested. Figures for traffic volumes, natural resources as a seabed, fishing stocks need to be accurately determined. So far as science and technology allows and correlated with natural geographic of the region, not considered or manipulated the strategic and military purpose. So bottom line of my argument is here. Marine sciences and technologies need to be redirected to comprehensively characterize the natural features and environmental of South China Sea. Only by establishing a mutually agreed set of facts about geology, geography, biology, etc., can maritime good order and stability be secured in the South China Sea. The current focus of legal issues is counterproductive, allowing false and misleading narratives to be propagandaed for the political and strategic purpose, and offering no hopes of ultimate solution. So my conclusion is cross cooperation among the regional stakeholders to create an objective pictures of South China Sea is much more likely to be constructive outcomes. Thank you for attention.
Thank you very much, Dr. Dun. The presentation is over 2 minutes. Okay. I agree with you that marine science and level technology need to be redirected to comprehensively characterize the natural feature and environment of the East Sea, and closer cooperation among community and state in the region and as a partner to create an objective picture of the region is much more likely to lead to constructive outcome. Thank you very much, Dr. Sun, once again. And now I would like to invite Dr. Peter Townsend Harris, Managing Director, Griff Adeno, Norway. Please, Dr. Harris.
Yes, thank you very much. I believe my presentation will be projected from your side. So if I can have the first slide, I'll just start off by saying a little bit about my organization, Grid Arendal. We're a small foundation based in southern Norway. We were created by the Norwegian government in 1989. Just click next. Next. Yes, to support the United Nations Environment Program, UNEP. We're a not-for-profit, about 40 staff. Our mission is to communicate scientific information and knowledge to create positive change. And science communication is the focus of our work. I'll be talking a bit about that in my presentation. And most of our work is in developing countries. A lot of my projects are in Africa and other places, although I have the pleasure of living here in Norway. The next slide. To give you a sense of the problem I'll be talking about is plastic pollution in the oceans. And this is a transboundary problem in as much as the plastic pollution that comes into the ocean from one country is transported by currents and lands on the beaches and coastlines and the fisheries of other countries. So a global issue that has to be solved by the global community. But next, if you click the button. The next thing I wanted to say is that the South China Sea region in particular is a hotspot for this plastic pollution. The pollution has many sources. It includes the shipping industry, fisheries, and in particular land-sourced plastic pollution washing in from the catchments and off the beaches of the coastal countries around the South China Sea. But the main point of this slide is just to show you that how the South China Sea region in particular is a pollution hotspot. The world produces around 360 million tons of plastic every year. Yeah, thank you. And rivers input some fraction of that into the ocean. We don't know the exact number, but this estimate by Le Breton projects around 2 million, up to around 2 million tons of plastic per year entering the ocean. A large part of that is coming into the South China Sea region. In fact, the next slide, this table lists the top 20 rivers in the world and their estimated discharges of plastic pollution into the ocean. And you can see that 6 of those rivers actually discharge into the South China Sea. They're highlighted in yellow there. And those 6 rivers together discharge something like between 150,000 to 300,000 tons per year, just coming in from the rivers. If you add together other sources like shipping and fisheries and just plastic washing in from the beaches and coastline, the number goes up to something like 1 million tons, 1 to 2 million tons of plastic pollution per year coming into the South China Sea, just the South China Sea. The global total is something like between 2 to 8 million tons. The main message I want to give here is that we don't have a very good estimate. We don't really know how much plastic is coming into the ocean, but it is a significant problem. It's measured in millions of tons per year. The next slide. I want to talk a bit about now is the technologies we have to try to understand how plastic pollution, like all pollutants, is dispersed once it is entering the ocean. And the presentation I'm showing you is based on a literature review I've conducted, and I'm sharing that with everyone. There's a paper that I've sent in to the community for this conference. That's all available for all to read, but this is just going to give you a few highlights. So here's a paper by Ko et al. Published in 2018. It shows plastic pollution washing up on Dongsha Island in the northern part of the South China Sea. And they make the point that there's quite a big difference between the plastic sources that plastic washes up on the beach here during different times of the year. It's quite different between the winter and the summer. During winter months, you get plastic coming in from the north, coming in between the Luzon Strait, between Philippines and Taiwan, and that washes up onto the beach. And then in the summer months, it's coming in from a different direction, from the southern part of the South China Sea, arriving on the beaches. The next slide, the next picture just shows you some of that plastic on the beach there. You can see it's not all coming just from the land. There's some evidence there of plastic and pollution coming from ships. So there's a lot of different sources of this plastic, this material, but it does wash up on beaches. So modeling, the next point here is a selection of things that modeling can do for us. It can tell, sorry, can you go back one? It shows you not only you can identify the sources and the sinks of this plastic using modeling, but you can aid cleanup operations. It can tell you where the plastic is going to come ashore and guide you to put your people on the beaches to pick up the plastic in the most effective ways. It also tells you which places, which coastal areas are the most vulnerable to the plastic coming ashore. The next slide. Then how do you measure and quantify this plastic pollution once it's in the environment? And that means you have to go out in a boat and you have to collect water samples and samples of sediment and samples of the biota to try to measure the contents. The bad news is we now know that there's plastic pollution in every single part of the ecosystem. It is not only the water and the sediment, it is also in the biota. There's plastic in the shellfish, in the fish, and you probably have some plastic in your own body, I'm sorry to tell you, because it is so pervasive. It gets into everything that we eat, and it is accumulating into the food web. So measuring plastic in the ocean is not easy because once it is in the environment, it starts to break down into smaller and smaller particles. And these particles are very difficult to measure. In fact, one of the issues is if you get a sample, you can try to extract the plastic from the sample. Then you got to determine if you have actually got plastic in the sample. This is a big issue. It looks like plastic. Things look like plastic, but they're not plastic. To be absolutely sure, we use new technologies. And this is one here called Fourier transform infrared spectroscopy to be absolutely positive we identified plastic particles in the water or in the sediment. So some other issues, just to try to get a handle on this, is how do you filter the water or the sediment to get the plastic? The size of the mesh you use determines the size of the plastic particles you're trapping. And this has a big effect on what you measure. Identifying the plastic particles is an issue, and converting from the number of particles to the mass is a big issue. If you're trying to model the mass of plastic arriving in the environment, it's not an easy thing to transform from counting the number of particles to the mass of plastic. And this is an unknown quantity in the environment in most places. The next slide. Okay, so my job is to try to communicate science to decision makers like yourselves and people in the general community. And my job in Great Arundel is to try to come up with ways to communicate this complicated information. Here's a couple of examples of technologies that we use to communicate science. We try to get information into understandable pictures like this one. This shows you the different kinds of plastic. Not all plastic has the same density. Some of it's lighter than water, will float on the surface. Other pieces of plastic are denser than water and will sink to the sea floor. And this diagram shows you those kinds of different types of plastic. The next slide is a quick summary of how plastic gets into the environment. Don't spend too much time looking at this, but it's meant to show you how complicated it is, because indeed it is a very complicated system. We produce plastic all through our economy, through our industries, our interactions with the ocean. It gets into the ocean in different ways. It accumulates in the fish and in the biota and in the sediment. And that diagram shows you that complex picture. Next picture is the next picture shows you the food web, how it accumulates in the food web, from the zooplankton right up through the pelagic fish into whales and into humans once we start eating the fish. Okay, so there are policy implications for all this work. And of course, the United Nations Environment Assembly that meets in Nairobi every year has passed 4 resolutions on this topic already on plastic pollution. There's a sustainable development goal attributed to the oceans, which is looking at this issue. There's a movement for a global agreement to understand plastic pollution and how it gets into the environment. I don't have time to go into all of these different issues, but my last slide is my conclusions. I see my time is out. Yes, communicating complex science is our job. The last slide is the conclusions. Next slide, please. Yes. So number 1 conclusion is that we need more data. We don't have a real good handle on this problem. We don't know how much is coming into the ocean. We don't know where it's going, and we don't know where it's accumulating. So we need to do much better data. In order to get that data, we have to work together. We need to cooperate and share information among countries in the South China Sea region in order to develop best methods and procedures to measure and control this pollution. And the role of technology includes effective ways to communicate and get those scientific messages out so they can be understood by the decision makers and folks like yourselves so that action can be taken. Thank you very much for your attention. Appreciate the chance to speak to you all.
Thank you very much, Dr. Harris. Your presentation provides the overview of the marine plastic debris in the region, in East Sea. And I think that this, meaningful story for most countries in the region. Actually, now for the ASEAN, we have the Bangkok Declaration on marine debris, and we have the regional action plan on marine plastic debris. And we know that now Norway and Germany are leading countries to promote the global agreement on marine plastic debris. I think that is very interesting. And for the reason, Vietnam, we propose the partnership on this issue addressing in 2018 at the Global Environment Facility Assembly meeting. And next year, the February, United Nations Environment Assembly will convene a meeting to discuss further on this issue. And thank you very much. And the science is very vital for cooperation in the region. Thank you very much. Now we move to next panelist, very close friend with the Mekong River countries and citizen science, Mr. James Poten. Please, Mr. Poten.
Thank you again. I'd like to express my thanks to the Diplomatic Academy for this generous invitation to be here. I think I'm going to have to speak like a New Yorker rather than a Southerner. I'm in South Carolina. But let's be clear. We are now embarked on a new era for ocean science and the potential for maritime cooperation. All of us understand all too well during this pandemic that science is a language for humanity, needed now more than ever. But we have all these technologies. We have the buoys, we have the AUVs, the ROVs, the gliders, the ocean observatories. There's an increasing amount of data available for ocean management. Unfortunately, too much of the data are never shared publicly. perhaps most challenging, is the data are easily disassociated from the very people who helped create it. So we can draw upon the Intergovernmental Oceanographic Commission, IOC, because they have recognized for decades that many aspects of ocean research present far too formidable a task to be undertaken by any one nation. And this is particularly true in the South China Sea region. Here we have, as typhoons continue to race across the region, let's give credit to the IOC, since they have gradually developed data and information exchange on sea level monitoring, drifting buoy program, the tsunami warning system. But more is needed. Let me take a look at that. I think decisions in the real world require negotiating between what we think the data means, what human value we'd like to assign to it, and what stories about it we can get others to accept. Data alone is not knowledge, and it's certainly not wisdom. It rarely says as much as we think it does. So this afternoon, your time, mine, 2 a.m., I'm offering a snapshot of the new ocean technologies, but mainly focus on marine citizen science or participatory science, often comprised of students that I've worked with, non-academic researchers, how it plays an important role in harnessing and releasing the important big ocean data to the public through social media, whether it be through Facebook or Instagram or Flickr or other sources. It is the bridge by which science, combined with access to data and society, can work together for mutual benefit. And as you can see in the helmsman wheel here, there are a lot of spokes to not only have safe passage in the South China Sea, but to inject science and what that means. Next slide, please. Marine science, now more than ever, is dependent on effective cooperation among scientists, labs, institutions, governments, and the general public. But here, I'm laying out a definition of what citizen science or participatory science is. The term defines a series of activities that link the general public with scientific research. Volunteers, non-professionals contribute collectively in a diverse range of scientific projects to answer real-world questions. It's building capacity. These non-scientists are even using their smartphones with the free downloadable science apps for data documentation. They're collaborating with expanded communities, eco-volunteer organizations. Next slide. We reach something that I've called kind of digital conservation. That is, if the public has access through their smartphones with these science apps, they're free, downloadable, then we can upload the data to the cloud, and it's become the first step needed to get data into a larger digital ecosystem. I mean, marine science has entered the digital age, and expansions in the scope and the scale of ocean observations and smart sensors now leads to a continuous flood of data. There's much activity within the oceanographic community to develop many types of underwater sensor networks, mobile, fixed, autonomous, cable. Next slide, please. And of course, we have the ubiquitous internet. Well, 54% of science information is now being gathered from the internet, and we find that more and more young people are being exposed to science, conservation, sustainability issues, and particularly as it pertains to the ocean. Next slide. Next slide. Okay. Again, coming back to digital conservation, since the science apps are free and downloadable for all, we're seeing this, well, if you wish, outreach, and that includes marine protected areas for data mining, data integration, and of course, their ability, that is the non-scientists, to communicate and experience the ecosystems. It's interesting that in the last couple of years, and I am an ardent friend of Vietnam, I spent a lot of time in some of these MPA areas. One of the places I went to was Kula Cham, just off the coast of Hoi An. And is where local fishermen and families are engaged in conservation and sustainability practice because of the role of citizen science. And one fisherman told me, James, we need to go large, but we must start small and get the support of all of our people first. Well, this idea of participatory citizen science, in fact, has done that very, very successfully on that particular area. And it is also, of course, being expanded to Lisong Island. Next slide. Citizen science is part of a kind of a public engagement to ensure that data is more accessible for decision making. New marine technologies connect data, but not always nations. We need the public engagement to lead the policy adoption. And that's something that has been missing for some time. So while the ocean technology advances have multiplied over this past decade, including the scale and number of cable observatories, acoustic modems, processing and visualization capabilities, the cooperation among nations to foster an open access digital ecosystem requires much more development. Next slide. I'm listing here some citizen science projects. They're not all marine based. In fact, I wanted to bring attention to one that's not listed there. It's called Reef Check. That's been very, very successful in its use in the Great Barrier Reef by non-scientists, if you wish, citizen scientists. In addition, the Open Networks Canada system has set up a program using a new mobile app called Community Fishers. So they've actually been part of this, if you wish, monitoring of overfishing in that part of the world. We'll go to the next slide and we'll just go forward again. Next slide. And next slide, please. Okay, I want to jump into this idea that there are models for the South China Sea for collating marine data. And this one that I've identified is from the European Union through something called the Sea Data Net. It's a distributed marine data infrastructure for the management of large and diverse sets of data from the non-space of the seas and the oceans. And there are also other examples that invite the participation of the communities in that. Next slide. Again, through Copernicus, we have this South China Sea model for collating marine data, satellite data, and other data, including the analysis and transformation into value-added data products, maps, and statistical data. Again, we have the public involved in this kind of collective outreach, working side by side with the scientists. Next slide. Here, I bring you to the attention of something called Zooniverse. It gives people of all ages and backgrounds a chance to participate in real research with over 50 active online citizen science projects. They're working with almost 1.7 million registered users around the world to contribute to research projects led by thousands of researchers. The idea is that we're going to continue to embrace, next slide please. Next slide. I'm going to make these real quickly. Let's go to the conclusion here. So that's the bell ringer. Conclusion. That ocean science brings opportunity for data sharing among the researchers and nations. It's generating new scientific process to inform policy. It's establishing new public-private partnerships in ocean observation and data distribution. It's producing a regional-wide ocean sustainability ecological model. And we are here at this conference, and all of us appreciate and understand how vital the ocean is. It covers most of our planet. We very much need to engage the communities, the people, with understanding the connection with our ocean. And ocean data cooperation in the South China Sea is more than possible, and it's vital for the successful development. And it's also a way to engage peace-building projects. But again, I thank you very much for your time this afternoon. Thank you.
Thank you very much, Mr. Bolton. Your topic is very interesting for us. I agree with you that the ocean data is very important for sustainable development. However, it's very difficult for the most country low developed and developing countries. And that is a room for cooperation among the region. Thank you very much once again. And now we move to the final panelist, Dr. Frank. Please, Mr. Frank.
Dr. Frank, you have to unmute.
Dr. Frank, could you turn off the mute? We cannot hear you.
You have to unmute.
Do you hear me?
Okay, okay.
Do you hear me
please?
Now? All right. So the idea is that I have a look at the meeting point of marine science and law. And in order to do so, what I try to do, is a short outline. I have a look at law and science. We know that they have different internal qualities. And at the same time, this leads me to an hypothesis, which I will then try to apply to two specific areas, one being definition of the continental shelf, and the other one, it's a body called ABELOS, Advisory Body of Experts on the Law of the Sea, which operated for some time and where lawyers and scientists were obliged to work together. And then I'll try to have some conclusions with respect to the South China Sea. So the starting point is that law and science are inherently different. If science tries to explain unknown facts by existing knowledge, and so trying to progress, I would say that law has exactly, or very often at least, the opposite kind of approach. It goes by existing behavior, which it then tries to regulate. So when those two meet, the idea is, how do we solve these contradictory notions together when they have to work together? And of course, the ideal solution would be that transdisciplinarity would prove the answer, meaning that scientists and lawyers stick together and try to understand each other. And in reality, unfortunately, and that's the hypothesis, very often when these two match, we see that certainly in the beginning, the idea of working together stands high, but as time passes, this ideal wanes in favor of scientists and lawyers retrenching in what I would call their comfort zones. So I try now to illustrate that by two examples. The first one is the notion of the continental shelf. It's a legal notion, which of course is to be found in the new Convention on the Law of the Sea and already codified in 1958 for the first time. But it has undergone quite some evolution, at least the legal notion, because in 1958, when we look at the definition, it's a definition which speaks about length and depth, and so it's two-dimensional. But today, in the new Convention on the Law of the Sea, the Constitution for the Oceans, we see that a third dimension has been added, because you also have to look on the inside of what constitutes the continental shelf in order to be able to to decide whether it's a legal or a non-legal continental shelf, and whether it relies or it depends from one country, or rather it belongs to another. The importance of judicial decisions in the law of the sea today has been very clearly established. For one thing, the area we are discussing now is that it was the ICJ in 1969 which added a scientific term to the definition of the continental shelf by focusing on the notion of the natural prolongation, which according to it was important. Unfortunately, in 1969, they could not apply it because in the North Sea, we had a uniform continental shelf. But by creating this notion, which was later on incorporated in the Convention of 1982, and which as such added the third dimension, today, with respect to maritime delimitation, it is the State Board of Ports which will have to apply it in practice when two states want to delimit their maritime zones. And this area, maritime delimitation today, and it's rather unusual in international law, has become a kind of judge-made common law, in the sense that if you want to know what the rules are which are applicable, you really have to analyze what the court and tribunals have decided on this issue, because that's where you find the legal rules about maritime delimitation today, not in the convention, unfortunately. But these courts and tribunals, even though they were responsible for the creation of the notion of natural prolongation, this scientific notion, they were also responsible for the quick demise of this same notion. Why is that? Well, it is sufficient to have a closer look at these three decisions, two by the ICJ, one by the International Tribunal on the Law of the Sea in Hamburg, to understand that when lawyers meet these definitions, it's very difficult for them to comprehend. And Tunisia-Libya of 1982 is an interesting case because that was the first continental shelf delimitation case after the 1969 North Sea continental shelf case. So what the lawyers of both parties did was to focus almost only on natural prolongation. Unfortunately, the lawyers of both parties came to totally opposite conclusions. And so what the judges at that time did was simply to state that since the scientists are not able to agree, what we have to do is, as lawyers, to look at other things, and they looked at coastal geography, something that they were much more at ease to work with as they had done in the past. The same in 1985, Libya once again tried to rely on this natural prolongation because between Libya and Malta you have a rift zone, and the ICJ in 1969 had exactly stated that a rift zone is a good reason why you should give more to one country and less to another one. But here, the ICJ decided that within 400 miles between two states, this notion of natural prolongation could not have any influence anymore on the legal definition of a continental shelf, because in the meantime, a new zone had been created, the EEZ, which had nothing to do with natural prolongation. And according to the court, other elements needed to be taken into consideration. So once you have no longer more than 400 nautical miles between two states, natural prolongation disappeared. So in the literature, the legal literature, you then found the idea, well, this natural prolongation will then pop up again when we are deciding about the extended continental shelves, meaning the continental shelves beyond 200 nautical miles. But once again, here, the IGLOS in 2012 came to the conclusion that this was not the case. They said there is no difference in the treaty between the inner and the outer continental shelf. So the same reasoning should apply on both sides of this 200 nautical mile limit of the continental shelf, meaning that coastal geography remained the only determining factor, apparently because the court is much more familiar with that. Let's then turn to the body of experts in the law of the sea. What kind of body is it? It is to be framed within UNESCO and within the S of UNESCO, science, where we have a body which has already been mentioned, the IOC, the Intergovernmental Oceanographic Commission, which, when the treaty was being established, needed some guidance on how it would implement their work because, of course, the 1982 convention for the first time introduced a consent regime for the EEZ. So this body, which is important because the composition was ideal to tackle the issue that we are dealing with, namely the body needed to be made out of scientists and lawyers in adequate proportions. What I'm telling here is based on personal recollections as I represented Belgium within this body during its existence for about 10 years now. But the practice proved to be very difficult exercise, not in the least because the treaty of 1982 does not give you a definition of a maritime scientific research. And so when they try to determine the legal regime of oceanographic data to be taken into account by the IOC, this proved difficult because some were of the opinion that it was part of marine scientific research, others were of the opinion that it was not. But if you don't know what marine scientific research is, it's of course very difficult. Now, what is the relevance of all this for the South China Sea? Since oceanographic data proved too vast, after a while the ABLOS narrowed the issue down to floats from the Argo project. And that's what you see here. What is specific about the floats is that they surface every 9 days, and then they make their scientific information that they gathered at 2,000 meters depth. They simply transmit it to a station, which then renders this information public to the general public, information available for everybody, as well as, of course, the location of these floats as they drift along because they're not able to steer by themselves. But from a legal point of view, the issue then is what happens if such a thing tends to drift into the EEZ of another country? One would say, or tend to say, that since it's in favor of the promotion of science, it should be a very loose kind of system. But countries were very much opposed. Some of them want to have the normal rules applicable, meaning consent, and that you needed to ask for diplomatic, through the diplomatic channels to inform the other one that something is drifting into their EEZ. Whereas other countries were of the opinion that since the system is open, the Argo system, it could be implied. Well, in South China Sea, the guidelines that were provided said that the system that should be adhered to would be one where the Secretary General of IOC would send a letter to all countries, and unless he received an answer from them that they required specific communication, the Argo system would be sufficient. But here we see, as you can read at the bottom, that China in the South China Sea is the only country which has, for the moment, asked for such official notification. And this brings me to my conclusions. And the conclusions are that when law and science meet, unfortunately, it doesn't always result, as it's stated, in easy sailing, meaning that bodies which are consistent of either experts in science or experts in law, like the CLCS, which is the Committee on the Limits of the Content of Shelf, these are experts, but they try to shy away from law, but sometimes they are running into it anyway, as also courts and tribunals have been running into these scientific notions, but they have rather retrenched in the legal notions that they know, meaning that they try to sidestep science when they try to apply definitions which nevertheless are scientific in nature. And ABLOS is kind of the same story. It was not too productive, and with respect to the South China Sea, an area which at present, unfortunately, does not seem to profit too much from the Argo project. This is my last slide, was already shown in the beginning. It's a slide from, or it's a picture from 3 days ago when I made my presentation. Very important to notice is that if you look at the South China Sea, unfortunately, from the 4,000 floats, there are only 2 present in this area. And the 2 which are present are both Chinese floats. So it means that even though the region is very prone, it has already been mentioned by this panel, to tsunamis, to tidal waves and things like that. So they could profit very much from the Argo project. Unfortunately, reality shows us that this so far has not happened yet. And with this, I would like to conclude my 7 minutes. Thank you very much.
Thank you very much, Mr. Frank. Your presentation is very interesting. I guess from your paper that there are both constraint and opportunity for science and the law of the ocean and the sea. And the scientists and the lawyers should go hand in hand to cooperate to implement the UNCLOS 1982. Thank you, Mr. Frank. Ladies and gentlemen, now we have a short time for discussion. So I would remind our participant, each person you have only 2 or 3 minutes for question. Now for the online participant, I see Mr. Hunter Martin. Okay, please, Mr. Martin. Okay, please.
Hi, yes, thank you very much. I appreciate the invitation from the Diplomatic Academy of Vietnam, and thank you to the panelists for all their wonderful remarks. I hope I'm not taking us in too different a direction. My own PhD project revolves around great power competition and Southeast Asian foreign policies. The panelists point to the potential for marine science and technological advancement to open pathways for regional cooperation in the South China Sea. But they also point to numerous areas of concern that science is being used to further individual nationalist causes, even fueling tensions in the South China Sea, or at best, it's overlooked amidst interstate competition for scarce resources and national security. Many panelists echoed themes of cooperation and conflict in the last day and a half. The balance of which Vietnam and other Southeast Asian states practice skillfully when managing great power competition. The presentations also underscored the asymmetry between ASEAN countries and China, the largest claimant and regional power. My own research on Southeast Asian states' foreign policies suggests that small powers have a great deal of agency to shape the behavior of great power competitors in the region through regional institutions such as ASEAN. Marine science and technology are one such area where ASEAN states can contribute to stability and cooperation in the South China Sea. But this will require enhancing intra-regional cooperation and trust with renewed urgency and overcoming nationalist divisions between ASEAN states. So this leads me to 3 questions. The first is, can ASEAN be in the driver's seat on science and technology, contributing to the maintenance of a rules-based order and reducing great power tensions? The second question is, can small powers shape the behavior of great powers and reduce the potential for conflict? Finally, how can external partners like the United States reduce asymmetry and promote regional cooperation through scientific exploration? And if the panelists want to go in a different direction, I understand that my questions are geared more towards geopolitics. I'm not much of a science and technology expert, but I'm grateful for the opportunity to contribute. Thanks again.
Thank you, Mr. Martin, your comments and recommendation. I would invite our panelists who would like to jump in. No? Okay.
Sure.
Sure.
Mr.
Bolton, okay, please.
Yeah. Well, maybe as the American president, I should talk about the new administration in Biden and how he places Southeast Asia in terms of his geopolitical roadmap. I think it's very, very important to him, and he's also, through some communication I had with people in Washington, indicated that he intends to focus on Southeast Asia and perhaps, as we get through the COVID passages, and we have much work to do in the United States, make plans perhaps in mid-2021 to travel to Southeast Asia. But I think it's of great concern that the United States, it's not as if they're going to take a Obama re-pivot towards Asia. It's just simply that the United States recognizes that it must send a stronger signal to Vietnam and your neighbors that indeed we do care about not only the free passage through the South China Sea, but an engagement that we have not seen on the part of the current administration. So I would be quick to point out that the new administration certainly wants to engage Southeast Asia, and that would be part of Washington's geopolitical response. Thank you.
Thank you, Mr. Bolton. Now our time is over, mostly over. So now I would like to invite one participant in this room. Miss Liang. Liang, okay, you raise your hand, please.
Yeah, thank you, Chairman.
Sorry, okay. Please.
Yeah, thank you very much, Chairman, for this opportunity. I would like to thank DAV as well for this great opportunity to give some comments. I would like to make 2 points. The first point is that in the Declaration of Conduct of Parties in the South China Sea, signed 18 years ago, 2002, had called on the relevant parties to conduct cooperative activities in 5 main areas, including marine environmental protection. That's one. Number 2 is marine scientific research. Number 3 is safety of navigation and communication at sea. D and E is search and rescue operation, and E is combating transnational crime. So I would say that the first 3 areas more directly concern our topic today, which is related to science and technology, i.e. marine environmental protection, marine scientific research, and to some extent, the third area, safety of navigation and communication at sea. But the first point I wanted to make is that it seems to me that cooperation on science and technology among the parties concerned in the South China Sea is very limited in nature. And I would like to ask the panelists how countries in this part of the world can actually so-called cooperate on the low-hanging fruits. Because as you guys have mentioned, cooperation in science and technology ought to be neutral. It should be science-based, more of science and less of politics, right? So in that sense, logically speaking, we should be progressing based on this basis. And the second observation I wanted to make is that one of the underlying assumptions of progress in science and technology is that this would logically promote cooperation among the parties concerned in the South China Sea. Yet, we see that this assumption does not appear to be the case with regard to the South China Sea. In fact, it appears that the reverse may be true, that as countries make progress in science and technology, it puts them on a stronger footing to assert their respective claims in the South China Sea. And I note that in the presentation by Dr. Yoon, you have very cogently argued and at this point highlighted this point. So my main question to the panelists is, certainly there are potential areas of collaboration which you guys have mentioned, but I think at the end of the day is we still have to answer this key question. Why is it that countries or the concerned parties involved does not seem to want to promote cooperation? And if we recognize this point, then we have to tackle the next question. How can we encourage the concerned parties to cooperate more by using maybe science and technology as a good starting point, since it is science-based and less, in a way, less political in nature? Thank you very much.
Thank you, Mr. Liang. Now, our panelists who may answer the question, Mr. Liang, Professor Malay.
Yeah,
okay. Please, Professor Malay.
I think the question. I really think that there has been going on a lot of cooperation in marine science in the region, as I have indicated, and many of my colleagues will attest to that. But the translation of marine science as objective to management will border into jurisdictional issues. And that is part of the reason why it has been mostly information sharing rather than taking into action that is holding off the information. There's a lot of science-based information for management. But we really think that with the nations now being more open to collaboration and sustainable development and inclusion, there will be more opportunities, as I mentioned, and also the demand for other sectors to cooperate. So I really think it's hard to expect science to be the solution, but I can attest to the fact that science has contributed significantly in goodwill, that the people in the region actually work together for many decades.
Thank you. Thank you, Professor Male. Now, final question in this room, please. Nobody? Okay. Thank you very much. It's the time for our session. Thank you all panelists, discussion, and participants for fruitful discussion. I'm sure that the exchange we have today may contribute to promote regional cooperation in future. Thank you very much once again, and we close this session now. Thank you.